Okay, good afternoon, everybody. And so very happy to have you here, to have you also online, people. And so yet another session about Argo. I mean, it's an oft quoted network, Argo, during this, I would say these 2 weeks, not only this week, but the week before too. But there are several aspects of it. And this afternoon, we will really focus on what the European role in Argo, the past one, the present one, and the future one. So without further delay, I will begin just by showing how we will manage and handle this afternoon. So this is a panel, and well, you're just counting right. Yes, someone is missing. So, so the Director General Shalina Vicheva just informed us this morning that she was not able to come, and either any of her colleagues, but she left us very kind messages that we will read, and so they will be very present, and because there's been this ocean pact, you'll see that I mean, her voice will be heard. So we have Alexandra Caccieri from DG Defis. Good afternoon. We have Karina Franchukman from Mercator and Siemens.
Hello, good afternoon.
Oh, okay. I think you have to press when you want. Yeah.
Should be on.
Yeah. And you have Brian King, who is from the National Oceanographic Center in the UK, but as a co-chair of Argo International. And myself, so I'm Jan Hervé de Rouek, and I'm the Director General of the ERIC, so the European Research Infrastructure Consortium, which is devoted to Argo. Okay, and what are we going to do? We are first having a tour de table, so each of us will speak shortly, and first a presentation of EuroArgo by Brian, its usage by Siemens, and its challenges by myself, and then there will be send the questions, and for the questions, so we were so happy to have a representative of the European Commission, and but the questions are also among ourselves, and please already think about the questions that you want to ask to the panel. So, Brian, give you the floor.
Good afternoon. Thank you very much. So I'm a co-chair of the International Argo Steering Team. I'm going to tell you a little bit about how Argo came into existence, because understanding how Argo came into existence will help us understand how Argo can now move forwards and the importance of one or a group of countries stepping up to provide real leadership. And that's what we want to tease out today. So the first decade, originally there was a design. The initial design for Argo was conceived in the US. The US stepped up with a design and when tried to encourage other partners to share in that design. And within a year, 8 other countries and the European Commission had followed towards implementing that design. It took time to build up the array, so there was an initial design calling for 3,000 floats. By 2001, there were 200. By 2007, we had first realization of the complete array. But the point is, it began by one group really going for it and other groups joining in. So some of the achievements from what we call the core mission. The core mission, it has real-time data delivery down to 6 to 12 hours for numerical weather prediction. The overwhelming majority of the subsurface three-dimensional ocean data that are provided for either ocean prediction or, for example, the reduction of uncertainty of the Earth heat budget. The next speaker will tell you more about that. We have helped describe changes to the planetary water cycle. If you're a country that is habitually afflicted with either floods or droughts, you really want to know about changes in the planetary water cycle. And we have transformed the amount of subsurface data for all kinds of research. We have widespread data delivery. It's freely available. If you want the full data set, you can go to our own Global Data Assembly Center. There's also the Copernicus Marine Service, which is one of the go-to places for aggregation of data with other data types or for value-added products. And we'll be hearing about that from the next speaker as well. So from 2010 to 2020, really we were exploiting and expanding Argo capabilities. The technology was working really well. The design was expanded to include the marginal seas, for example, very obviously the Mediterranean. Under ice capability was developed. Enhanced sampling in certain regions, such as the tropics, particularly the tropical Pacific. And then the biogeochemical sensors got to the stage where they could be deployed on unattended platforms. Oxygen, nitrate, pH, chlorophyll fluorescence, particle backscattering, and incoming solar radiance. Also, the deep capability was developed down to full ocean depth of 6,000 meters. And both the biogeochemical and deep capability required the development of new sensors and new platforms capable of delivering those sensors to where they were needed. There are also geographical extensions and enhancements. Those led to a fleet of about 4,000 floats, more than the initial design because of the extra things that we were now trying to do. So then, as the biogeochemical measurements, the deep measurements, they had particular ways that those communities preferred to do things. But to be efficient, we brought it all together into what we're calling the EuroArgo design that combines the original core mission and the biogeochemical and the deep measurements. So at the Ocean Obs 19 conference, which kicked off the UN decade, the EuroArgo design brought together all of those newly published missions, including the emerging polar mission. Floats delivering the biogeochemical and deep missions would also be required to meet the requirements of the core mission for maximum efficiency. And planning and program governance has also been consolidated into single meetings of a steering team. So compared with the core mission, the EuroArgo design includes more under ice floats, the polar mission, enhanced sampling in the tropics, enhanced sampling in highly variable western boundary regions, and that's a total of 4,700 floats, 1,000 biogeochemical floats, 1,250 deep floats, and 2,450 other floats just delivering core profiles. And there's a diagram in the right-hand side there of what that looks like. There are all kinds of new applications possible with the EuroArgo design. The deep measurements enable us to do further improvements on understanding sea level rise and the heat budget, the contribution to sea level of simply warming up the ocean that's there and expanding what's there because you warm it. We can track deep circulation, ocean overturning. We can figure out what the deep ocean looks like before and after deep sea mining activities, and kind of as a free byproduct, you can find out information about the deep sea bathymetry, because when a float reaches the ground, the seabed, with a pressure sensor, you know exactly what the ocean bathymetry is. The biogeochemical measurements, there are all kinds of applications. You can global views of deoxygenation, acidification, ecosystem monitoring. What happens with marine carbon dioxide removal? Does the carbon dioxide stay in the oceans or come out again? And what impact does it have while it's there? We can also look at enough of the ecosystem with forecasting to manage living marine resources, and we can look at the health of the ocean with some of those other parameters. So by the time EuroArgo is fully implemented, we know from talking to the modeling community that those modeling communities will, within 5 years, be running models to predict ocean ecosystem parameters. They will need data to both initialize and validate those models. So towards implementing EuroArgo, nobody says this is a bad idea. Everyone who's commented on it says, yes, that's a good idea. Why don't you go and do it? It really is a question of resources. At least 12 of the UN decade actions just say that they're going to utilize the data from EuroArgo without actually knowing if those data will be there or not. They are not yet funded. The global annual cost of EuroArgo to realize that entire global effort with all those parameters would be up to 100 million euros per year to be shared across any number of global partners that participates. Since float lifetimes are about 5 years, you just have to deploy 20% of the floats every year, and eventually you reach a sustainable standing crop. So it should take 5 years from when we start till when we arrive with a full implemented array. The biogeochemical array is about 40% complete, so it would reach 100% quicker. And the deep array has many basins with no observations at all, so it will take the full 5 years to get there. So earlier this week, the World Meteorological Organization put out a briefing. It's only a 2-page document, and in it, I counted 8 references to either past results or needed future actions in which Argo is either a central or the majority or the only likely source of data for those things. And here are some quotes. It talks about record ocean heat and acidification, harming marine ecosystems, record ocean temperatures and acidification inflicting severe and long-lasting damage, having an impact on sustainable development of the ocean, billions of dollars worth of damage. These are all things that the WMO said this week are challenges in the ocean which the One Argo program, if implemented, will enable us to address. So I'll pass over to the next speaker, who is going to be Karina, and she will tell you more about some of the applications of Argo data that we have seen so far.
Thank you very much, and thank you for the great introduction of this unique observing system component to cover the full ocean. So I will present you some slides from work which has been done at Mercator from some specific experts who have identified the dependence or the strengths of the observing system, particularly Argo, for the forecasting or ocean prediction systems. So this is just a general overview on what is an ocean prediction system, which provides you the core for the ocean monitoring and for the core forecasting systems with so-called data accumulation, where you put together the theoretical knowledge for the modeling together with the observations, so in situ observations like Argo, but also observations from remote sensing from satellites. And then, this in order is used, of course, to provide the reanalysis system, to write the ocean forecast and monitoring activities. But what it also provides is a strong feedback loop in order to inform where we do need to fill gaps of our ocean observing system to ensure that we have a strong and powerful prediction and forecasting for the ocean. Without observations and without full observations, we will lose quality or even skill of the forecasting and prediction system. So it allows us to get information of what we can do. So as you have seen before, Argo is a global, unique, it's a revolution for the measuring the ocean. And it's a revolution measuring the ocean starting to be mostly global in 2005 and 2006, between 60 north and 60 south up to 2,000 meters. And with all the evolutions we could achieve today, as I just introduced before. So this is just to show you the data, but you have seen this before at the surface, but for only at depths, with a different type of measurements. And you can see here the majority of the blue information coming from the Argo float. So if you look at how it impacts your system, your model system with assimilation and also doing these tests of including, so you see that you can have a strong bias in the period where you don't have Argo measurements. And so if you, as close as you come to the observations, you see that this forecast skill highly relies on the availability and quality of assimilated observations. This is another example, so deep Argo. So we have a look into the 3D of the deep ocean, where we have information from Argo up to 2,000 meters, but with the new evolutions also below. So this is another strong argument, besides the strong cases you have made for climate and also socioeconomic implications. It is also with respect to the skill of the monitoring system, where we significantly reduce the biases of our forecasting systems and model systems, assimilation system in the deep ocean. Here we see another example also on the biogeochemical aspects. So these are tests have been right where there had been a regional scale, where had been some pilot information or pilot information are available. So international parameters, optimized parameter means there had been an aspect of considering the observation in the model, and in the right hand you have the comparisons with the satellite observation showing how the information of these data are essential in order to improve the skill of the forecasting system also for the biogeochemical parameters. And then I would like to finalize this presentation with the core information, also the importance of Argo, with respect to the ocean as being the sentinel for planetary and future warming. So what we can observe, we have observed this in the past, but with a lot of differences because the ocean was not covered globally. And since Argo, we reach a larger agreement. And what we learn is that the ocean is warming. And what do we know if the ocean is warming? We know if the ocean is warming that the Earth is out of energy balance. So meaning that less energy is leaving the system as compared it is receiving from the sun. And it is leaving less system because we have this imbalance due to the effect of greenhouse gases, which is reducing the outgoing heat energy. So heat is accumulating, and it continues to accumulate. And why we know this? Because we see the ocean, because 90% of that heat that is accumulated is stored in the ocean. So the ocean helps us to mitigate climate change, but pays also the huge price. And so knowing about the ocean, we know about the heat available to warm the ocean, but also the atmosphere, the continents, and also heat available to melt the ice, and for the changes today and changes to come. Thank you very much.
Thank you very much, Karina. And especially, we should really thank you for the coordination of the Ocean State Report, which is really, really important, in fact, in the understanding of what's going on in the ocean and its evolution. So now I'm going to talk about the European share, the European contribution to EuroArgo, again today and what should be in the future. So first of all, what's an ERIC? An ERIC, this European Research Infrastructure Consortium, is in fact based on, in our case, 12 countries, which can be members of the European Union or associated countries, like Norway and UK. And also we have one candidate, which is Denmark. And so we are coordinating the contribution of these various members. And, but in fact, in each of these countries, you have a national Argo program. So at the whole in Europe, you have 30 entities of different nature. You have some academics, and you have some Met offices, and you have some institutionals that collaborate to acquire first, and so acquire, procure, test, and deploy. And then also perform all the data management, and data quality. We didn't stress so much about that, but there's a big effort done in real time and also by expert after a delay, but which really provides very, very accurate data. And so, well, maybe I already said it's in fact so far. So, but what happens is that around 25% of the fleet is managed and supported by Europe, and we have specific interest in Europe. That's for sure. We have a big interest in marginal seas. I mean, who else as Europe would go into the Mediterranean, the Black Sea, and the Baltic Sea? And also in the Arctic seas. And so we have really initiated, and especially not far from here in Villefranche, many of the experiments in BGC, in biogeochemistry. And we have a big, big interest in this. And also, I mean, with the US, I would say, among the only countries that have so much also pushing for the deep, for the deep part of Argo. And we also have operational services. So we serve both the scientific, the researchers, but also operational users. And so Copernicus, we'll talk about it again several times, and both Siemens, but also for the satellite sector with calibration and validation. And in some countries already, Argo data have been used for the Marine Strategy and the Water Framework Directive. And we do not just work by ourselves, we work with other marine research infrastructures, especially for trying to shape up common operational tools, working a lot on common metadata and bricks of the future European ocean observing system, and throughout some European projects we do that. Okay, then, okay, I said 23% for the EU contribution, and this is the US contribution. So I'm beginning to talk about the challenges, while you're all aware of the geopolitical situation, and these 53% are on threat, not yet, not today, but for sure in the coming years, or at least won't keep at this level of contribution. And well, if you have different colors here just for the US contribution, it's because you have, like we have in Europe, several partners, but the main sources of funding are the NOAA and the NSF. And also, if you heard about the news, these are their budget also on big threat. And I've added this one too. This is the European contribution to the various, in fact, sectors of missions of Argo. So, like Brian said, I mean, even before really quoting it or naming it EuroArgo, there was already some biogeochemistry and some deep experiments. And so it was tiny in 2008, but after that, you have always two colors, a shaded one, which is the share of Europe in these missions. And for BGC, for instance, as last year, we were quite good. For core, a little bit too less, and for deep also, it was very much missing. And about the targets here, these are figures. If we were aiming to have 30% of supporting for supporting the EuroArgo. In fact, I think this figure is also, this sketch is also interesting to show. This is the contributions of the various countries, of the various members, and it's you know, cumulative count. But on the top, because I really think that the way it should be thought about, you have the top up of Europe. I mean, throughout dedicated projects, and there's been a very large. There has been a very large project which was called MOCA, which brought over more than 120 floats, and it was, I mean, really a big asset to adding up to the contribution of the various countries. But now there's nothing to really replace, just some research projects on which a few floats are bought, and you see that it's contributing to the overall decay of the European contribution, because already members are facing troubles with the fact that BGC floats are 3 times more expensive, 4 times more expensive than the core ones. The deep ones are twice more expensive. So I mean, for the same budget, you have to provide floats for the various missions. At the whole, the number of floats is decreasing. Okay, so although, well, we are ready, in fact, for EuroArgo. First, like Brian showed, I mean, the global community, and with a lot of European contributions also in exploiting the data, is really has a very good track record. And also, well, from the very beginning, our data are open, free, shared many times. I could also show the many ways of accessing the data, not only EmonNet, on Copernicus, but also nowadays on the cloud, and with several kinds of formats that make them machine readable, for instance. And we also have commercial suppliers in Europe, at least in assembling, so like NKE. And we have the data management, both for the European side, so the Data Assembly Center for Europe, we have two of them, one in the UK, one in France. But Coriolis is also performing the Global Data Assembly Center, which is twinning the efforts that the US is doing. And of course, you have Copernicus. And of course, also, we have the luck, I would say, I'm happy to say that, the luck of having an Eric for this network, which is not the case for all marine networks, of course. So that's also something to be shown. And so we have good infrastructures. And look at the number of active floats. Again, this is maybe figures to be really a little bit commented. Is the number of active floats, what it amounts as a percentage of active global floats, but what are the respective GDP and okay, what is in fact this is measuring the effort, the respective effort that is performed by the various countries, by the US on one side, by the members of EuroArgo Eric, and in fact, as I said, we have two associated countries. So when adding up, we also have to add up also their GDP to get these figures. So there's something to be done, and that's one of the questions that we will raise. And okay. Okay, so what are in fact the challenges? Well, we have to implement this big step forward on BGC, Deep, and Polar. We need to raise our share in the international Argo program, that's for sure, and also. I mean, OneArgo is also conceptually something new. So, do we, and that's the title of this afternoon, as Europe, want to have the leadership on that? And I think that's also one of the important questions. Questions that, please, Alessandra.
Sure.
Yeah, I give you the floor.
Thank I have only one slide, so can be just this one. So good afternoon, everyone. Also by my side, I just have one single slide, and then we can go on with the question and answer session. I will present you quickly the Copernicus in situ component. Also to remind the importance of the in situ measurements for a system as Copernicus is. We had yesterday afternoon here, more or less at the same time, the nice session on the call for the ocean prediction advancement, and the keywords also there, coming also from the Ocean Prediction Symposium that was at the end of November, was observation. And in Copernicus, the in situ data component is meant for observation in situ, geospatial reference and ancillary data, licensed or provided for use in Copernicus. The purpose of it is production and validation of Copernicus product and data service across all the Copernicus services. Of course, here we are reminded of the Copernicus marine part. Then they stand alone as observation products. As it was reminded yesterday by our colleagues of GOOS and of ESA, with satellite, we can go at the surface, but we cannot go in the deep. So we need in situ measurements. And then, of course, we need for calibration and validation of satellite sensors. And ultimately, we need for our prediction systems. So it's really key for all the system, and particularly for Copernicus. What is done within the in situ component is that basically each entrusted entities that is leading, and you are seeing on the side the different entrusted entities involved in Copernicus. They manage and use in situ data daily to meet their own operational needs. But we have this component as cross-cutting coordination steps, and EEA is the one who is leading this, for having a coordinated and programmatic approach across Copernicus. What I can tell you is that we are discussing this element also in the Copernicus User Forum. Yesterday, in the Copernicus User Forum, we had a session dedicated to have an overview on the Copernicus dependencies on the on the US supported in situ measurements. And that is extremely important because our member states are responding with a strong support in this for building then the vision of the in situ strategy for the next monitoring, for the next MFF, for the next funding cycle. That would be 2028 and 2024. So the idea is to have an enhanced in situ strategy for the next MFF with a couple of elements that would be maintaining the continuity on the current time series and building on existing arrangement is also a crucial step for us. The in situ strategy will contain a pillar on strategic and cost effectiveness, and we are looking to address also strategic autonomy. The important part is that Copernicus would like to be resilient and autonomous, which doesn't mean that needs to be necessarily completely independent. And I would like to conclude my point with the fact that we want to reinforce the in situ component and we want to keep the in situ part high in the agenda of the Copernicus User Forum to involve our member states in this discussion. Thank you.
So thank you very much, Alessandra. So now, so Charlina had also sent us a slide in advance. I mean, because she was really supposed to be here. So this I have it for a couple of days already. And she wanted to talk as an initial presentation about the Ocean Pact that, if you remember well, has been announced on especially this week with the President von der Leyen really quoting it and a big presentation on Monday. And main message is that the ocean observation is a foundation of marine knowledge, our only pathway towards credible science, efficient policy making, and a competitive, sustainable blue economy. So the link with blue economy, the first time we talk about it this afternoon, although, I mean, it's of course underlying for what Siemens is doing for sure. EuroArgo, as part of OneArgo, is a cornerstone of the global ocean observing system. Sustainability and longevity of the system should be a common priority through tangible action. Tangible action, this is a clear message, I think. The European Commission is already undertaking work with its member states to increase coordination and transparency of ocean observation, aiming towards efficiency gains, observation gaps reduction, and support of EU technological innovation. And then the conclusion is what, of course, Charlena would have said it much better than me, but that through the EU Ocean Pact, the European Commission commits to launch an ambitious ocean observation initiative which will connect, scale, govern, and secure European ocean observing capacities and will actively secure collaboration with international partners to secure and support global infrastructure we all depend on and in funding, including, of course, OneArgo. Yeah, so that was all for the first initial roundtable, and I think that we have to be short now on the question. But the question we had already, I mean, preset for 4 questions, and the first question was, in fact, for Brian. So, what is the advice that the OneArgo community would give to Europe, to the members of the Commission, to be able to step up with OneArgo?
Yeah, thank you. Can I have the next slide? Can I? Is there? So I prepared a slide on this. So I think the answer I would give now is very different than if we were having this discussion 1 year ago, for example. So as I described with the start of Argo, the best chance for OneArgo to become a reality is if one nation or group of nations, the European group of nations, for example, chooses to commit to implementing OneArgo and then expecting others to follow. Now, I would say now, it is unlikely that the US will be that nation. First time around, the US led by committing to half, and other nations followed. It is unlikely that the US will be the lead in this. So I would say, if Europe wants and needs to see EuroArgo become reality to provide all our data needs that it can, Europe should take that lead. Now, a year ago, we'd have been talking about Europe doing 25%, because we've done 25% of the existing array. We might have said, we will do 25% of a much expanded array. If we want to see this, if we don't want it to just dribble away into the sand, probably Europe has to commit to doing 50% of what is done in the way that the US committed to doing 50% of the original program. So even 3 months ago, when Jan Hervé's slide, it showed Europe at a quarter. This will probably no longer be enough to get EuroArgo into existence. This requires something like 50 million euros a year across the partners, not all from the European Commission, but across national programs. European countries will need to find about 50 million euros a year to make this a reality. Now, there might be, that would include any direct contribution from the European Commission. This is an increase by a factor of about 4 over present European funding. EuroArgo is twice as expensive, and Europe's doing twice as big a share. Now, research funding managers have made it very clear that the funding required for Europe to deliver 50% will not be found from research budgets. It will just require an act of political will. As with, for example, defense, when the European heads of government decided that they were no longer going to rely on others for defense, they just decided they would find the money to pay for it. This needs an act of comparable an act of political will. If Europe decides it is not going to depend on anybody else to provide the global observations that Europe wants to see made, at heads of government level, we will have to decide that this is something that Europe wants to do for itself. And if Europe does half, I'm pretty sure other nations will step in to do the other half. Europe leading EuroArgo would ensure European policymakers, agencies, researchers, and so on have access to the data that they need. If the World Meteorological Organization wants to make good on all that stuff in its press release, if it wants to see the ability to monitor acidification of the global oceans, this is the program, probably the only program, capable of delivering that. If we want to see a world in which we understand ocean acidification below the very shallow surface, below what you can do at the surface with ships, if you want to know about ocean carbon flux into the ocean at the moment, you look at surface ships. You don't look at the moment at the inventory. We saw when we started measuring ocean heat content, the uncertainty in ocean heat content collapsed to a tiny fraction of what it was before. If you want to see the same with carbon parameter measurements, this is the only game in town that is offering to do that. Basically, the economy, we keep getting told the blue economy is worth billions of dollars, billions of euros. If you want to manage that economy, then this is a relatively small investment.
Thank you. Thank you very much, Bahrain. Yes. Thank you. That's a clear statement. Then we have a second question that is for Karina. What are the needs and expectations vis-à-vis EuroArgo and EuroArgo? What are the prioritization of needs? I mean, what is really the necessity to fund further than just research program, observation and data acquisition like it is in Argo?
Yes, thank you for this question. So it is clear. So a service like Copernicus Marine is providing the data for in situ observation, the data products from remote sensing, and also the reanalysis, and also the forecasting. So these are data which are providing us information over the past to understand the ocean. They're providing us information to get a glance of what is happening today. And we get information for the forecasting so that we can be alerted. And there are also new ways of constructing projections, for example, which allows us to have an ability to anticipate. So if Argo fails to be there, we lose the fundamental baseline. We lose the information for the observing in the deep ocean from the in situ part, and then we lose also our skills, the strong skills to get information, to be up to date, and also to alert. So I think these are the strongest arguments to state why we need to ensure that Argo keeps its power and that Argo extends its power as well to ensure that it informs us all in terms of the health of the ocean and all our socio-economic links.
Thank you very much, Karina. Yeah. So then we have another question for Alessandra. How does DigiDefis plans to face in-situ data requirement of Copernicus services in light of stagnating national investment, increasing cost of in-situ ocean observation, and geopolitical changes? What is the future in-situ strategy of Copernicus? You already said a few words about that.
As I was mentioning before, we are very well aware that we need to have an enhanced institute strategy for the next MFF. Because of all the reasons that we have been listening now, including the geopolitical scenario in which we are moving in this moment. What I wanted to share is that this strategy is under development. We have started right now. As I said, Copernicus User Forum discussion was really yesterday, so it's something that is in our agenda. You know, the Copernicus User Forum is collecting all the member states and is meeting every quarter, so it's a discussion that will be ongoing. And the European Environmental Agency is now coordinating the development of these strategies and is supported by all the entrusted entities, and the discussion is very well supported by all member states. So we have received a good feedback, and I think this is a clear, good sign. And what we are planning to do in the next, keeping this in situ component element high in the agenda of the Copernicus User Forum, is to continue the discussion for better identifying the gaps and understanding what are the corresponding mitigation action. Of course, not only for Copernicus, but also coordinating with all the other elements that are coming within the Commission, the Ocean Observation Initiative that you were mentioning and everything. So we need to coordinate to be able to face these challenges.
Thank you very much, Alessandra. And then there was another question for who was for Charlina. So how does DG Mare plan to address the needs for Argo data and other institute data in light of stagnating, again, the same environment? While ocean observation is a cornerstone of ocean policy, like the MSFT, the monitoring, and a strict requirement for all the ambition that the GMI has in EMONNET, just been quoted also at the last session, and the EDITO, the digital ocean that is shown here. And so I have here some messages so that I got this morning at the time of the cancellation of the venue of Charlina. The importance of EuroArgo and OneArgo as baseline resources that fundamentally support the work of a wide range of stakeholders across different sectors is a given. No question about that. Okay. The European Commission's response through the Ocean Pact shows a comprehensive and ambitious plan giving ocean observation the necessary place and attention. At the foundation of marine knowledge, the source of comprehensive marine data, the fuel behind digital applications. Digital applications here all around. The Ocean Pact is very ambitious in that account. The European Commission will step up efforts by launching an ambitious ocean observation initiative, including for the coastal and deep sea, assuming a leading international role, that's important also, to deliver critical information to all marine actors and sectors. And she added up the Ocean Observation Initiative, which will cover observation campaigns, governance and coordination of ocean observation at the European level at least, data processing, infrastructure, and the provision of key services will be the next chapter in the discovery of our planet's inner space and will connect, scale, govern, and secure ocean observing capacities. So that's what we hear about EUs and all this future here also. Through this action, the European Commission recognizes and aims to support the different components of EuroArgo and OneArgo and other fundamental ocean observing infrastructures too. I mean, it's not just the case of Argo and Monaco. That was the response from DG Mare. I think we have time for one question if you want. I mean, otherwise we're almost over time. But does anyone have a question? Yes?
Can you give examples of other fundamental ocean observing infrastructures that are being considered?
Well, the drifting buoys, I think.
That was a question for DG Mare, was it? Or
that was a question. Yeah, but for each of us, yes. What is important for us? Yes.
I can talk about the structures that I think are important. So, to me, within GOOS, within the Global Ocean Observing System, it seems to me there are three networks that are truly global, truly coordinated with a definite plan, which are the float program, as represented by Argo, the ship program, as represented by GoShip, and the surface drifter program, which provides all the surface data buoys that provide a lot of information for driving numerical weather prediction. So of those, the Drifter program and Argo provide data for short-term forecasting, and Argo and GoShip provide the data for understanding climate change on a decadal scale. But those are the three programs within GOOS that are genuinely global, genuinely coordinated, with all the participants working towards a single plan. So to me, those are the three legs on which sustained global observing can stand.
Karina, you have a complementary? No? Okay, let's go to the next question.
Yeah, it is not a question. Basically, I think it is imperative that we need to face the challenges, what we are expecting. So I think it is all the countries together has to join and come up with this 50% of Argo. I think towards this, India especially, we have enjoyed the Argo data, especially for monsoon and other things. So we are able to convince the government that it is important. So I am sure that from next year, next 5 years, from next year onwards, we will be minimum, at least we will double the contribution. That's sure. But at the same time, it is, I think all the countries has to come forward to go for much more than, because it should not be one country. Even I don't expect that even European Union has to come. Tomorrow, if it is change comes, then we have to go. But it is to be global. So that is the way we have to go ahead. I think that's each country locally what is important, and globally what is called important, that we need to substantiate to the government. Then, and also we are advocating other countries to contribute. So just it is a comment.
I mean,
Thank you. Yeah. Just a very, very last question.
Thank you. Fei Chai from Xiamen University, China. Thank you for step up on the stage, committing 50% from EU. I have a little bit good news to announce. From Xiamen University, we have 30 BGC Argos to be launched in 2026. So a little bit of contribution. But my comments are really for the panel or the people in the room here. How can we engage with the industry to bring down the cost of producing the Argos and the sensors? I can tell you, the sensors I buy will cost twice the cost you buy in Europe or in US. So we need to consider the cost, to bring down the cost of producing the Argos floats.
I think we. Pardon?
Hi, thank you. Lynn Talley from Scripps. Great stump speech. Brian, come on over to the U.S. and talk to our program managers. So we are, as I think has been hinted at, in kind of a sad place in terms of especially the biogeochemical Argo float funding. We've developed a program. It's global. It's 500 floats by the time we're done deploying next year. We still have about 150 to put in the water. But we will be ordering no new floats as of now, which means that things will start falling off a year from now as the lifetimes of the floats are reached unless a miracle occurs. So miracle, funding from someplace. Second miracle, funding to other countries to really step up. It's very, very important. And that this be really a global effort, not just a National Science Foundation effort, which is kind of how kind of where the biggest component of the global BGC Argo is now. Core Argo has so much strength and it's hanging on by fingernails. But as you've mentioned, there's a big need to maintain these systems, the long ones that have been running for a long time and the new emerging ones that have so much promise.
Okay, thank you very much. I think
if I could just make a very brief comment to appreciate those contributions. I think the contributions that we had from India and China is exactly what I was referring to. That if one group steps up and really shows a strong lead, there will be other groups that will say, we will follow. There is now a viable global program and we will do our share. And that is the way Argo's existed. As I said, first time around, the US did most of the heavy lifting and has done since. Getting BGC off the ground, as Lynn described, the US did much of the heavy lifting to get that where it is now. It is time probably now for the next few years, other groups have to shoulder some of that heavy lifting to make sure that the momentum is maintained. I have no doubt that the US will come again as a heavy lifter, but for the time being, the other countries are going to have to step into that role of shouldering the burden. And the contributions from everybody are just wonderful to contemplate.
Thank you very much. Thank you very much all also. And we have to make a picture? Okay. Thank you again.